Okay, this one can seem overwhelming, so let's just read through it carefully. The table below gives values of f prime, g, and g prime for selected values of x, specifically 1 and 3. And then they give us this that looks overwhelming, but it equals 8. And then find the value of this. Now, upon examination, we'll realize that this is f prime g, this is f g prime. Okay, sounds product rule-ish. It is. This is going to be the same thing we've been doing this entire lesson, obviously. It's going to be integration by parts. And so I am going to write the formula, and that's going to be, we'll just do it up here, the integral of u dv. Personal opinion, if you write the formula a lot, you'll memorize it. So every problem, just take the opportunity to write the formula. Really. Integral of v du. There we go. So we need to identify some stuff. How do you know? I don't even know what I'm looking for. I got this and I got this. Here's a strategy that I have found that works. In questions like this, they'll give you a whole bunch of stuff, and in the process of just doing what you think is right, morally and mathematically, sounds like a motivational speech, you'll encounter that. And trust me, you will. So I look at that and I say, I bet this is this. Let's just start working this out, and I bet that's going to show up. And in the process of that showing up, I'll find out what it is. Like, I'll solve for that. So the first thing I need to do is identify u and dv. And then everything else will fall into place. And then we'll also have du and v. And let's not use blue this time. We'll just underline these two. These are the two things I'm looking for. Okay? So dv is in here, and u is in here. So up to this point, we've had functions, we've had sines and natural logs and polynomials and all kinds of stuff. But now it's just f primes and g's and stuff. So I want to be able to take the derivative of something and take the antiderivative of something pretty easily. And here we go. If I chose f prime to be this, then I'd have to take a second derivative. I know nothing about the second derivative, so don't choose that. So this is not f prime, this is f prime, and because it's dv, we'll put the dx with it. Notationally it works, because if I took the integral, I'd be working backwards. Okay, no secrets there. Well, u is the thing that you can take the derivative of. And again, I could take the derivative of f prime, but then I'd get f double prime. Second derivative, don't have information on that. So if I put g here, I'd have the integral of g here. Well, good luck, you don't know about the integral of g, right? So sometimes you just don't have the information to work the direction that you might think you ought to work, so use something else. All right, here we go, g. Well, the derivative of that would just be g prime of x dx. Okay, using this formula, this structure, we're going to just, plot along, work some things out. I'm going to write the whole thing down, and I will continue to use purple. I'm going to need a lot of space here. I've worked this one out twice already, and it took a lot of space. So let's do this with small handwriting. The integral from 1 to 3, pause right there. This is a definite integral. It's not indefinite. Okay, every problem we've done in these notes so far has been indefinite, but now it's where I'm evaluating it with the fundamental theorem of calculus. I plug in a 3, I plug in a 1, I subtract them, I get values. We'll cross that bridge in a minute, but don't ignore that there's a 1 and a 3 here, clearly, okay? All right, integral from 1 to 3 of f prime of x, g of x, dx equals, it's 8. I know it's 8. We'll play with the 8 later, not a big deal. Equals, okay, let's work on this, uv. Okay, well, uv. That would be g of x, f of x. Okay, I'm going to pretend like I'm forgetting something, and I'm just going to move on. Leave a little gap because I'm not forgetting. Minus the integral, definite integral, 1 to 3, of v du, so f of x, g prime of x, dx. Okay, first of all, I would like to point out that I am wrong. Don't change anything, because here's what just happened. Because it's an definite integral, I'm going to evaluate as much of it as I can from 1 to 3, right? Now, why don't I do this one too? I haven't integrated this one yet. Am I going to integrate this one? No, it's what I'm looking for. See it? Okay? So all this equals all that. Let's keep going. At this point, simplify as much as you can, because this is going to get really sloppy really fast. It already has. Do you know what this is? Of course you do. They told you. Well, let's plug in the 3 into both of those. Okay, so I have g of 3, f of 3, minus g of 1, f of 1, minus the integral from 1 to 3 f of x g prime of x dx. Oh, sunlight's starting to come through right up here in the corner. Record these about the same time every day, and the sun just comes through and illuminates the mathematics. Coincidence? I think not. Okay, g of 3 is 5, f of 3 is negative 3, minus g of 1, which is negative 6, f of 1, which is 2, minus this stuff that I don't want to write every time, but to be mathematically correct, I will. Okay, so we have 8 equals negative 15 plus 12 minus the integral of the thing that I'm tired of writing every single time. That's okay. The next step will be the final answer. So final answer is when I get all this by itself. Actually, I'm going to just pick this up and move it to the other side and make it positive. So the integral from 1 to 3, because that's what I want. That's what they're asking for. Integral from 1 to 3, f of x g prime of x dx. As abstract as it seems, that's just what they're looking for. Equals, okay, well, negative 15 plus 12, that's negative 3. Negative 3 minus 8, it is negative 11. We found it.